Have you ever tried to envision the shape that a plate will take under load? Being able to do so is important for understanding how plates work. It is also important for identifying regions with high curvature and moment and points of maximum deflection. We designed this model to help students better understand plate deflection. Let's use it to investigate a square plate with simple supports, as indicated by these dashed lines. The white grid makes it easy to see the shape that the plate will take as it is loaded. As you can see, the curvature is positive, like a smile, everywhere and in both directions. You can also see that the maximum deflection occurs at the center of the plate. If we now clamp one of the edges, denoted by the solid line, we discover a negative moment, like a frown, along the clamped edge. The same thing would happen if one end of a beam were changed from a simple support to a clamped support. A simply supported plate that spans two bays takes this shape, and it exhibits both positive and negative curvatures. If we remove the center support, we get a rectangular plate, and it takes this shape under load. Notice how the curvature across the width of the plate remains nearly constant until you get near its ends. Notice, too, that the curvature in the long direction is nearly zero except near the ends. If we remove one of the end supports, the plate deflects like this, and removing the other end support produces this result. Notice how bending occurs in only one direction. If a slab is curved in only one direction, the load must be carried entirely by stresses in that direction, and it is called a one-way slab. If the supports cause the plate to curve in both directions, we have a two-way slab. Carrying of the load is then shared by stresses in the two directions, and deflection is reduced. Floors in buildings are often supported by columns, as in this model system. As you can see, the deflection pattern is quite different from that of a plate that is supported along its edges. And here is a column-supported plate that spans two bays. Suppose we had a floor with an overhang. How do you think it would deform? Here is what the model shows us. Just for fun, here is one more design we can build with a model. Can you understand why the plate takes the shape it does? Understanding plate curvature is especially important in the design of concrete floor slabs. The reason is that concrete, like the blocks in this model, cannot be relied on to carry tension. Consequently, steel reinforcing must be incorporated any place that tension could arise. And that includes the tension side of any regions where bending occurs. That is why it is important to know the direction and degree of bending at every point in a plate. You might be wondering about the weigh scales that are part of the plate bending kit. They allow you to investigate how load is transferred to supporting columns and beams. They can also help you to understand tributary areas, a topic we don't have time to discuss here. Thanks for watching.